with the SolREI company. This is part 2 of In Unification's Wake, set of informal charts on Elegant Reasonism. This particular topic is mathematical proofs and how we need to think about those in the new context as opposed to the traditional context. The fundamental premise has not changed, but the details have. So let's go through that. Just so you know, in case you haven't seen the other videos, this chart deck and all the other ones are in the user library on solrei.co, SOLREI.co. You do have to register and go to the user library under Info, off the menu there, and there's a SolREI folder, and the presentations are there. The best way to view these charts is to log into the website, have it off in the background, bring up the PDF file, and then any hyperlinks that you see in the presentation that you might be interested in, just click that and it will resolve to the respective page back into the website. Hope that helps, and that should be a path to the detail that you might be looking for. There is a note here on this particular presentation, and that is that the original systems review that we did had over 400 equations in it, and needless to say, some of those were pretty complicated. But what we did, or what we are working to do, is to establish those as fundamental concepts, and we enumerated them 1 through whatever they are, 405 or 3 or whatever it is. And for each one of those concepts, we have to mode shift the concept. And so that means that there's likely multiple sets of equations associated with that. So we have a page for the concept. That page links equation pages that articulate this detail about each one of the equations. So from a taxonomy point of view, how that plays out is that you'll have a concept and then some number, a hyphen or a dash, I forget what we use for that, whether it's an underscore or a hyphen. And so that concept number. And for that same number, you'll have a set of equation pages. That'll be EQ underscore M, the model number, whether it's 1 through or 0 through 6 for the 7 recognized models. And then that way everything kind of stays together, and you can navigate that in clumps if you want to. That's just a way to think about how we've tried to communicate these things. So that detail is there, and also just to make a point, it's kind of should be obvious, but if we have 7 recognized models and there's over 400 equations, that's 7 times 400 number of web pages that we have to build. And so we're having to go through the body of work that we've had over the last 16 years and build out that massive number of web pages and all the detail. And so we're a very small company. So, you know, the task is daunting. Please bear with us as we work to get that information out there. Obviously, we have a lot of work to do. We need help. If you want to help us and have the resources to help us, then call us and maybe we can figure something out. So mathematical proofs have been around for hundreds and hundreds of years by now. The traditional mathematical proof structure, I would say, is essentially the same in the sense that you're trying to meet rigorous requirements and you're trying to articulate that. What's different is that Elegant Reasonism recognizes Langer epistemology errors. We also recognize model encapsulation. What do those things mean? The details behind those are on the earlier videos. But essentially here, it means when you encapsulate a model, that's 100% of that model. And that means all the context, all the definitions, all the formulas, and everything it takes to recognize what manifests that context. We have to do that for each of the models that are employed in any given investigation. And so if you choose M1 and M5 for your investigation, then you have to have everything for M1 and then everything for M5, and then the tools and processes will juxtapose those two across the set and bring out the translation matrices to employ that. But there's more to it than that, and you have to do this with industry standard QMS principles. That's quality management system standards, or standard systems. And you need to use ISO 9000 Unification tool or its equivalent. We don't care whether you use ours or make up your own, but it has to accomplish the same fundamental capability. And the one that we've implemented is relational. It is not a simple flat file. If you're a computer person, you know what that means. After you've done all that, that's the only time that you can holistically employ the methods and tools of Elegant Reasonism in order to accomplish credible alignment with the unified universe. And after you've gone through this a couple of times, you'll understand what I mean by that. The big picture here is essentially that predominant thinking is logically correct, but therein lay the strategic flaw discussed in Langer's book, 1948 book, Philosophy in a New Key, in the sense that humans and the human physiology intrinsically produces abstractions in order for us to relate to the world around us. And that's the Achilles heel in empiricism. Empiricism, the fundamental or foundational common element between the traditional epistemologies is exactly that human physiology is a component of them all. What we've tried to do here is create an epistemology that seeks truth as a function of the unified universe that's independent of human physiology. It uses it, and in that sense, it is a superset epistemology because it leverages empiricism and rationalism and constructivism, but it weights those things statistically as a function of the fact that they don't close to unification. And so then exacerbating all of that from a articulation point of view, and as we all begin to communicate with each other about these, is that there's a historical schism that transpired about 300 or 400 years ago as philosophers began to use experiments and laboratories and processes that could be duplicated and shared. That was one of the reasons that drove written proofs, mathematical proofs, so that you could then hand that piece of paper to somebody else, and then they could duplicate that and come to the same conclusions that you came to. The assumption there, however, is that everybody is looking at the same information from the same context. And as we just talked about, one of the things that changes here from interpretive model to interpretive model is actually that context. And so it changes, and so that changes the patterns, it changes the math, doesn't change the mechanics of the math, but it changes the parameters that are used in the math. And so the patterns look different. And the values associated with a given thing might be slightly different because those structures and constructs are different. But within any given encapsulated model, the same integrity requirements that you might have for a traditional mathematical proof in the context of M1, that same integrity is expected in every other model. So whether you're talking about M2 or M3 or M4 or M5 or M6 or even an M0, that integrity must be assured within the context of how that model manifests the various paradigms of interest. And to go from model to model requires us to use a translation matrices and establish mode shifting mechanisms. And we do that with the tool, and we talked about that in the earlier videos. Okay, let's see. All right, so recognizing the logic traps from the inside. If M1, for example, it's not that it does not close to unification, it can not close to unification. And so the core constructs of M1 preclude accomplishing unification. And that's something we'll talk about in another video when we, we're now going to start a whole new series. This series is called In Unification's Wake. We're going to have another series on the original systems review and a number of videos for that. And in that other series, we will talk about what we had to do in order to recognize that we were in a logic trap and all the different things that we had to do to get out of it. And the result of getting out of it and all of that exercise resulted in the establishment of the emergence model that we now call M5 and M6. And we talked a little bit about that in the earlier video. So anyway, the mission of the remainder of these charts here in this presentation is to help everybody understand that while you're operating in a logically correct manner and employing a logically correct interpretation of reality, would you be situationally aware of having committed Langer epistemology errors? And most times people are not, because they're in a room full of people who all have the same understanding of how a given concept is defined. And when they're all in agreement and it's all in a logically correct interpretation, you have to look for other clues, and you have to ask deeper questions, and you have to keep asking questions. You have to keep asking why. It's like a little kid asking their mom, well, why is this true? Why is that true? And an answer comes, and you just keep doing that, and finally they pester you to death. But what's required here is a degree of intrepidity and pursuit of the reasons something does or does not close to unification. So what are some of these clues that are left? Well, one is that rationalizations they get ever more complicated. Sometimes even discussing some of those things requires very high specialization to recognize the flaw even in that thinking. And what all of that does is it manifests obfuscation for innocents, people who are not familiar with those things. What comes to mind here is that Einstein once said that if you cannot explain something simply enough, you don't understand it well enough. And so our contention is that Elegant Reasonism does not require a PhD to understand or comprehend or employ or wield. And but if you're not aware of these logic traps that we get caught in, simplicity is lost, and all these divergent theories about why this or that is or is not true just kind of become flotsam in the way of what you're trying to get done. Another one is a lack of a geometric basis point. Anything crossing the space-time mass interface is converted to energy. That's why you can never have the same geometric basis point to describe the solar system, for example. And that's also why people are having such difficulty running after quantum gravity in an M1 context. So another example is insufficient time for a concept development consistent with reality. An example there is BX442. It's a grand design spiral galaxy. Those galaxies take about 11 billion years to form using gravity models that are pretty much accepted. The problem with BX442 is it's almost 11 billion light years away. The universe is only 13.8 under M1. That doesn't leave enough time for it to have formed in the location we find it. And so we call that a concept compression issue. And there's a bunch of those kinds of examples. When reality does not support concept corollaries, an example here is in the Big Bang. There's a period in the very early stages of that we call rapid expansion. And that was rationalized as needed because it just can't get to the size the universe is that we find today in the WMAP data. But the issue with that is the corollary of rapid expansion is infinite compression. And what we find is that black holes grow. You can pull up any long laundry list of black holes from the smallest one to the biggest one, and you'll find out they grow. And because they grow, you can't rationalize rapid expansion with infinite compression. Because if infinite compression does not exist, actually what you can't reconcile is the growth of black holes and infinite compression. And because we know in science that black holes do grow, we know that logically infinite compression cannot exist or does not exist in nature. And because we know that does not exist in nature, its corollary cannot exist. And that means rapid expansion does not exist. And that kills the inflationary theory, and that all collapses, and we have to have another way to rationalize that. And we have done that in a page on the website called Bang to Bang. So you can go look at that and see all that data. Model integrity is empirically high, but will not close to unification. M1 is an example of that, as is M2. You can have all the empirical evidence you want. If you're inside a logic trap, what comes to mind is when Carl Sagan did the Cosmos series, he was talking about the flatland people in the 2D world, and they, that to the little flatlander person in his diagram, that is that's all they knew, and so their logical integrity would be empirically high to them. Anyway, that's a different discussion, but that's just an example, a quick example of what we mean there. Because Langer epistemology errors are when we believe an abstract is actual reality, that's a fatal flaw in epistemology. So if we make those errors and we believe that the abstractions we're working with are actual reality, what we fail to recognize is the ability to encapsulate that model. We don't see any need to encapsulate the model because we think that what we're doing is describing reality when in fact we're describing abstractions of it. And so that tends to silo the thinking, and it chains us to the wharf that the logic trap is. You want to get into the habit of tweaking facets rather than iterating encapsulated versions of it, and that's a key facet of what Elegant Reasonism expects you to do. One of the things that we try and do is make sure that we are not committing any Langer epistemology errors, and that we are iterating encapsulated versions instead of falling into the trap in the belief that we're working with actual reality. There's a fine line distinction there, and we always want to say that we are reflecting reality. We are not describing or defining it. We are defining descriptions of something that is the reflection of it. We want to get very close to it. We want to say that we are trying to get just as close to reality as we possibly can so that we might engage it better. And in fact, you'll see that that's what the goal is stated that way on the patent. Which is now published, by the way, by the USPTO, and there's a press release on the website, and you can go there and see it and read it, and then look at some of this video and other videos kind of all at the same time and start trying to digest all of that. But the point here is that Elegant Reasonism creates the framework and the epistemology so that we can holistically become aware of all of these different implications. So what is a mathematical proof? Traditionally, the standard definition for a mathematical proof is an inferential argument for a mathematical statement showing that the stated assumptions logically guarantee the conclusion. What Elegant Reasonism brings to the table is the framework to do the same thing, but with a plurality of encapsulated interpretive models against a given set of paradigms of interest. And then we take all of that, run it through the process that we have for the framework, which is the recognition phase, the illumination phase, and the analysis phase. And then we look towards developing an aligned treatise, and we have rules for that. And then the final treatise is reflecting a function, as reflected as a function of the unified universe. But we take all of that and put it over the top of an analytical stack to make sure that there's nothing in the way and that we are on target for, we're not committing language epistemology errors. We understand the abstractions. We understand the relationship stacks and the pattern shifts. We can mode shift the concept between interpretive models. It's kind of like learning to drive a manual shift car for the first time, if you know what I mean. The first couple of times you're going to grind the gears, but as you get through this and work your way up to being a professional race car driver, as an example, you know how to shift gears and downshift and whatever. But so the point is, you can come up with any number of metaphors you want to. But the point is, once you've done this a couple of times, you'll get more and more comfortable with what has to transpire in order to change the mode in which we are thinking. And that's why we call it mode shifting, because it's more than just stuff on paper. It's the way we have to think about things. We also want to make sure that we have the philosophical predicate priority considerations are in the context of what we call the realm of C's. They're words like cogent, coherent, cohesive, close, like closing to unification. And then there are metrics with all of those that can be embedded in the analytical stack that is the translation matrices. And then you can calculate things like Six Sigma and answers to the 5 why questions to do root cause analysis. And we want to do all of that in industry standard quality management systems, frameworks that are ISO standards. And you can find those on ISO.org. And then when we realize, at least in the way M5 is developed, the emergence model concludes that everything real is a system or a system of systems. And that just intrinsically requires systems engineering practices, processes, and guiding requirements to guide requirements for specifications for different things. And so we want to make sure that we're engaging the systems engineering kinds of skills to go through these kinds of thought processes and documentations, and et cetera. And then we want to support systems reviews whose objectives align with the unified universe. Because it's real easy to say you want to do something, but if that objective comes from the point of view of being within a logic trap of M1 or M2, for example, then it may be completely disconnected from the unified universe. You have to have a give and take there to make sure that your objectives for a given investigation are going to align with the unified universe. And so there's some consulting there that probably needs to be done. Compelling proof. So what does it mean for a mathematical proof to be compliant with elegant reasonism? Well, first of all, they have a fully compliant treatise that is aligned, it reflects the unified universe. Such proofs result of having completed the entire process and gone through all the rules, and you've met all those criteria, and you can document it with all. If you want to do a formal proof, then you need to be able to document that with all of the different metrics and processes and quality management requirements, and you can go out there on the web and see that information either on our site or the ISO site. You want to make sure that Langer epistemology errors are documented, quantified, codified, and ultimately reconciled in the context of the unified universe. And that's what we tried to do with M5. If you look, one point here is that if you look at, if your mode of thinking is predominantly being guided by M1, you can read that cogent definition, that one paragraph of M5, and you can read it all day long and you're never going to get it until you realize that M1 is logically correct and may be set aside, and that M1 and M5 are simultaneously logically correct. They're both true at the same time. You can't read that paragraph in context of a belief system based on M1. What you have to do is mentally you have to say to yourself, okay, M1 is logically correct. I'm going to set that down and look at it as a logically correct model. Then I'm going to take M5 and put it alongside it, and I'm going to realize that they are both logically correct at the same time. And then on the side of that, I'm going to put my paradigms of interest down, and then I'm going to say, how does that paradigm of interest manifest in M1? How does that paradigm manifest in M5? Oh, okay, I can write those two things down. And you keep going down the rows of all of your paradigms of interest. And pretty soon you're going to find that you'll have what we call the 2D articulation layer between the two models for your given investigation. And then you'll be able to start mode shifting between the two. And when you can start to do that, it's when you want to flip that up on edge and then go down the analytical stack of a translation matrices and really flush all of that out, and then bring it back up again. And then you'll be seeing all kinds of insights that you weren't even thinking about before. It's amazing. It's awesome. So there's rules associated with all that. We want to go through the realm of C's. We've written that down. It's on the website. And as you do that function, all these insights are going to be illuminated for you, maybe for the first time. But you have to be ready for shifts in the kinds of questions that you ask, as well as the answers that you get back. And one quick example that I'll give you is that in M1, if you look at Newton's laws, or if you look at in M0, if you look at Newton's laws, and we just say somebody asks, the first law of Newton is telling you what happens. Might be F equals ma, force equals mass times acceleration. That's what happens. It's not necessarily why it happens. And when you look over at M5, you'll find that M5, it's intrinsically obvious why it happens. And so there's a different, and the point that I'm trying to make here is that there's a difference between the standard what, when, why, where, and how questions. They get mode shifted between M0, M1, and M5, and so you have to be careful that you want to make sure that you're situationally aware of which model you are talking about as you go forward in any given investigation and in any given conversation. And we talked about that a lot in the last video. Okay, so the realm of C's we've mentioned, and you can read this chart too. But they are a set of words actually that came from business planning in the information technology industry. When we write business plans, we want to make sure that they're cogent and they're cohesive and they're coherent and that they're communicative, etc. All those words apply here with great meaning. And when we realize that the closure to unification is one of those C's and add that into that mix, there's a set of questions that you wind up asking that you didn't ask before. And so as we go through some of the examples here, you'll see better what I mean. But I encourage you to register on the website, log in and look through these different C words and see how they relate to what it is we're trying to accomplish here. So the encapsulated context, the process of encapsulation is a concept of isolated integration of a domain of discourse, but in this case it means absolutely everything required to reflect the unified universe, unified if the model can in fact be unified, holistically consistent with the Elegant Reasonism. Because M1, M2, and M3 will never close. So they can't, because the core constructs preclude that. And we want to make sure that we've at least identified all the Langer epistemology errors. We want to make sure that as those things are paradigms of interest are mode shifted across, that a review of how Langer epistemology errors may or may not be part of that mode shifting effort. And so if you've committed Langer epistemology errors or Lees and are ensnared inside the logic trap, whose artifacts conspire to create the illusion of cogent mathematics, you will never discern nor distinguish the elements necessary to escape the trap. And M1 is such a trap. And that's that bullet point right there is the basis of the other series of chart decks that we're going to do on the systems review that we originally did. And we'll show you how the clues that we saw forced us to realize the logical nature of M1. And as soon as, almost the instant that we recognized the logical nature of it, we were aware that we were in a logic trap, and that we had to go back and figure out all the different facets of that trap, and that's the subject of that other set of charts. Hopefully, we'll get those out soon. Because model encapsulations insulate and isolate one model from the other, the view of reality is completely made manifest by the constructs internal to the given model. And it doesn't matter what model that is, whether it's M1, M2, M0, M5, M6, it doesn't matter. The implication is that we talked about human physiology as it relates to empiricism. There's a ton of information about the traditional epistemologies on the website that you can go look through. And we're working to make that more solid as we can, or as solid as we can, and so that we can articulate it any given point in as clear a manner as possible. The equation patterns are a little different. So, for example, in M1, we think that mass is variant, and so there's inertia parameters and momentum parameters that get handled differently than they do in M2, where mass is invariant. The same thing is true in M5 when we consider action and the dynamic nature of configurations of MBPs. And so we can take those three, if we just looked at the single thing, the concept of mass across those three models, that's an example of pattern differences between the models for the same subject. So if the paradigm of interest is mass, and we're trying to establish all the different things we have to do to mode shift that from one model to the other, and we set all that up in a translation matrices, we'll see that those patterns are in fact different and distinct model to model to model. And we can mode shift that. And then we go back and we ask the question, which model closes? The only model you're going to find that can close is M5. So anyway, that's what that's talking about in that second bullet, sub-bullet there. Excuse me. Result numbers for the same paradigm of interest may be different exactly because those patterns are different. So don't expect the same kind of numbers from two different models. They're going to be different. And that should be obvious because the considerations are different. You're going to have different numbers. But that's not the issue. The issue is, are you assuring integrity within each encapsulated model? That integrity must be there. It must be assured. So it must be true for M1. It must be true for M2, and it must be true for M5 or M0. And that's how we check those things. But as long as the integrity is there inside the encapsulation, then and you can check that a number of internal different ways. But then when we juxtapose them and we come outside with the holistic view, kind of the overarching view of the translation matrices that presents, is when we start looking at the insights that come as a result of all of this. And again, I just said this a minute ago, the epistemological set constituents of known knowns, known unknowns, and unknown knowns, unknown unknowns, model to model will shift very dramatically in some cases. And so you just have to be ready to expect that the answers to the standard questions of what, when, where, why, and how shift as you mode shift things. And Newton's laws are an example of that. So, mathematics, the challenge in Elegant Reasonism is to reconcile all of those issues through a standardized framework with a standardized set of analytics to manifest as a function of a juxtaposed plurality of encapsulated contexts established by the employed interpretive models. So if your investigation needs M2 and M5, you might also want to use M4 for emulation purposes to ferret out different aspects of whatever it is you're looking at. But the framework layering and its metrics perform critical analytics to seeking truth as a function of the unified universe as a predicate priority consideration. And I would add the word philosophical in front of predicate there. Context, remember, context is established as a function of encapsulation. And you can read these bullets. But the issue is that the mathematical domains of discourse are parsed by the relative and respective areas of translation matrices. So each interpretive model represents a domain of discourse. Each analytical layer represents a different domain of discourse. The paradigms of interest, those are also a different domain of discourse. And so the translation matrices job is to take all of those different domains and allow you to create a capability to shift your thinking model to model to model relative to that set of paradigms of interest, and do it in a and when I say quality, I'm talking about business management quality. I'm talking about things like the National Baldrige Award quality metrics. There's a whole process with quality metrics where things are documented, and you can show where information came from and how you came to that conclusion. Same thing with the 5 whys and root cause analysis. Same thing with ISO 9001 QMS standards. We're using those things to define these different areas. So we're not just writing things down willy-nilly. We're doing it, we're documenting it, and so that once we're all done, we have a set of deliverables that would be the treatise. It would be the ISO 9001 Unification tool data file, which is a relational database, by the way. It's not a flat file. And any of the details that you use in support of your translation matrices that you constructed or you've completed for your investigation. And you have to show that with a set of against the set of rules, and show that how each step and stage that they were compliant. So the nomenclature that you'll see as we go through the emergence model and apply it relative to those 3 phase steps: recognize, illuminate, and analyze. You'll see words like, and all these the blue here on this chart are linked back into the website, and so you can click any of these and go back in. And I'm not going to go through each of these things here. They're here as a link guide so that you can link back into the website. I'll just tell you that real quickly that we spent a lot of time talking about encapsulation. The other probably not new word, but new use of the word is entanglement. It's the emergence model has 2 fundamental processes: the fundamental entanglement function and severance. And the severance limits the first. So proper way to say that is the fundamental entanglement function is limited by severance, and you can write that mathematically. I'll also tell you that the entanglement function is fractal, which adds even more complicated stuff here. But anyway, there's the equation sieves are a tool that we created that are just sets of math that goes with any given investigation. Ours had 400 and something with it. At least the first one we did. Then the standard reference frame for interacting real objects in the emergence model is something we call the event frame, and it has 7 phase steps. And we'll go over those in another video probably. ISO 9001 QMS system, QMS standards, etc. And if we were in a live audience, I would be probably taking questions on this. But for the purposes of what we're trying to accomplish here, these are standard business areas on the right-hand side there, mostly things like root cause analysis, Six Sigma, systems engineering. Here is in the context of INCOSE, which is the professional organization for systems engineers. And other things we've already talked about at least a little bit here. The emergence model is holistically comprised of two encapsulated interpretive models. One logical, which we call M5, and the other one is physical, which is we call M6. And I talked in the earlier video, but I'm going to reiterate it just a little bit here. There's an emotional need almost for people to want to jump to that physical thing and say, well, I'm dealing with the reality and I'm looking at real objects and here it is and I can knock it on the table and see here, pound on the table. The point that I would make is that there's a number of physical different ways to accomplish the same function. We draw logical diagrams all the time for everything from software components to houses that represent logical representations of things, and we can logically describe things with great precision. And an example is an interferometer, where we logically define the processes that we go through to determine what the speed of light is. And we have ways to measure and do that with great precision. Those are logical representations for that function. And it is a logical representation. An interferometer is a logical representation, and this includes LIGO, by the way. So it is a logical representation because we can come back to an M1 description of what's transpiring in, for example, the light interferometer gravity observation systems, LIGO, that are in Louisiana and in Washington State. We can describe that in M1 circumstances, but we can also describe it in M5 circumstances. And what happens underneath the details may be radically different one model to the next when we mode shift them back and forth. But the point is we can, in fact, mode shift them back and forth, and both models are simultaneously logically correct. One asserts that we have gravity waves in space-time, and the other one says, no, we have waves of gravitons. But the two descriptions of what transpires may be the same at some level, but underneath that, the descriptions that transpire underneath, the reasons those things are true are different. And when we drop back and say, okay, well, does the M1 description of what's transpiring there, can you close that to unification? Well, the M1 answer is no. The M5 answer is, well, yes. So which answer would you take, M1 or M5? My answer is I'll take M5 every day, twice on Sunday. So philosophically, you have to ask, does it close to unification? And there's a list of bullet frames here, bullet points that you can go through and read those yourself, but I'm not going to read them to you. But those are that's the emergence model. And because the emergence model has a logical and a physical view, if you will, M5 and M6, but because M5 is where we define the most precision, that's the model we wind up working with the most, M5. Almost no work has been done on M6 because we need a computer that's probably an order of magnitude larger than Summit, and Summit is the largest computer on the planet. So there's some investigations there that represent probably the largest computing opportunity humanity may ever have. We're trying to ping the National Science Foundation's radar and other organizations on that. And we have ideas on how we might, resolve some of these issues. But those resources and ideas are still in a conference room. Anyway, moving on. The implications are that M5 is the logical view of the emergence model. And again, it enjoys more precisely defined inputs and outputs. And we talked about some of that. So, for example, from a mathematical point of view, since that's the point of the discussion here, real objects are mathematically represented by the set of complex numbers. It's the complex symbol C, and generally taken as a vector quantity. And we also will put use imaginary numbers to transition, for example, from the event frame phase step 1 to event frame phase step 2, when we're also using something we call a local frame. A local frame is a non-interacting frame of an object surrounded completely by space. And so we because it is surrounded by space, immediately implies that we can't measure it, we can't see it, we don't know its location. There's a lot of like quantum mechanical things that we don't know about that, and the only way to know is to interact with it in some way, and interaction by definition requires us to move to an event frame from a local frame, which means we're no longer in EFPS2. And so we can move from an imaginary set of circumstances to a real set of circumstances across the event frame. And for example, the solar system, if we modeled that in an event frame, we would say that the geometry there is discontinuous, even though we know we have intersecting vectors, because it's the real objects have to transition across the dimensionless nothingness that is space in M5. And so we use imaginary numbers for that purpose. Lowercase subscript denotes mass, and again is a vector quantity. Event frames and local frames recognize real geometric objects, and again may possess discontinuity as a function of the way that they are related to a holistic whole or a constituent within a composite configuration, and quantum rotors might be an example of that. All real objects are MBPs or configurations of them that may be construed as systems or systems of systems made manifest as a function of their intrinsic nature. That means that when we went through our original systems review, we came up with the notion of the most basic particle. And if we take the MBP, an individual MBP, as a system, then all of the configurations of them are systems of systems, and physical properties are made manifest as a function of the structure. So you've heard the phrase structure equals properties, and properties infer intrinsic structure. If you replace those words structure with architecture, you now have a very good feel for where M5 is headed. And if we take the fundamental entanglement function limited by severance to follow knot theory, we then can trace it up through string theory and out into the rest of, essentially the rest of the universe. Time is an action displacement index, and energy is construed as the ability of these complex architectures to accomplish work. So those are some of the implications of M5. We've talked about encapsulation. Again, these bullets here. Is there anything here we haven't already mentioned at some point? No, I think so. But this chart is just to remind us about encapsulation establishes context for a given mode of thought and a way to think about the universe. So there's ways to think about the universe in terms of Newtonian mechanics in M0. There's ways to think about the universe in terms of relativistic physics in M1 and in M2, and the distinction between M1 and M2 is whether or not you consider mass to be variant or invariant. And then there's ways to think about it in M5 as well, etc. And so the process of encapsulation creates a boundary that is not penetrated, and neither in reality nor by the rules. Elegant Reasonism rule says thou shalt not penetrate encapsulation except in the analytical layers of translation matrices to establish insight. Mode shifting. Mode shifting is the ability to, once that translation matrices are, once the set of once the set of translation matrices are established for your investigation and they're completed, they allow you to mode shift paradigms of interest from one interpretive model to the next and explain how the different facets are made to come alive in that other model. And again, models are completely encapsulated. You cannot describe M5, for example, from inside the confines of M1, and vice versa is true as well. You have to mode shift them across the tool. Common terms about mode shifting. You have to have the definitions. The definitions have to be defined somewhere. They have to be quantified and codified. And we do that in our ISO 9001 Unification tool. You can actually download an empty version of that tool on our website. It is a relational database, and it will only allow you to do things within the framework of the definitions. It won't let you duplicate things. You have to iterate things, etc. Mass in M1 is simplexly defined as a quantity that resists force, whereas in M5 it has that same character, but it has a further characteristic that it is comprised of complex, composite, potentially discontinuous configurations of MBPs. Quantum rotors are an example of discontinuous configurations because there's a rotor that rotates around an axis, and it doesn't touch the axis. It just rotates around that. So there's actually two constructs there. Remember that M5 essentially positions all real objects as some configuration of MBPs resulting from the fundamental entanglement function limited by severance. You can't say that enough, and you'll wind up saying it to yourself so often that it's like, and once you start seeing what that means in terms of your investigation, it just becomes second nature. When we realize that an individual MBP is as a fractal initiator of a rope segment in knot theory, we then have a mechanism for the emergence model to come back through the fractal geometry of nature and manifest actually the entire universe. And it is amazing to think about it in that terms. I'll talk about that in a different video. Dr. Mandelbrot he was an amazing man, and I had the rare opportunity, and I'm very grateful for it, for having crossed his path when we both worked at IBM. In any event, severance clues can be illuminated or mode shifted in the reduction mathematics leading to the Einstein coefficients for emission. So if you don't just look at the coefficients for emission, but you look at all the math that leads up to those, there's a fairly long equation that is shortened, so the terms in the equation cancel out and they leave the equation, and they are, ironically enough, the term that gets canceled out there is C, and it cancels out in the equation on paper because the photon left the system. An industrial engineer would go, oh, if I was doing a process and something cancels and leaves, it has to leave through a pipe somewhere. It has to go something has to move away from the rest of the thing. And that something in this case is the photon. And so, and we take that's a whole discussion all by itself. But anyway, so there are clues around in the existing body of work from a mathematical point of view have been suggesting all of this from the very beginning. We just were running so fast, we just ran right over it. Some quotes from Winston Churchill come to mind, but I'll leave those for another time. Okay, so the framework tools are essentially two primary tools. The ISO 9001 unification tool and the translation matrices. This is, the unification tool is where we document, we quantify and codify all of our different definitions for the abstractions that we use for every model and at every order of complexity from the simplest to the most complex. And I'll just speak for just a minute about when you see our tool on the network and you download it, you'll find out that it's empty. And we did that on purpose. A lot of people are probably going to get mad at us about that, but we didn't think that we were in a position to declare to the rest of the earth that our definitions were the definitions. And so we would very much support and enjoy and love to participate in a worldwide work effort to come up with the standard definitions of what everybody wants to include, and then we'll host that version of the tool back on our system and give it back out to everybody. But we didn't want to be the ones to declare what those definitions were. So our tool is empty. It's not that we don't have definitions for those things. It's just that we don't, we have opinions and we're biased on certain things, and we think the international community needs to come together, have discussion and debate, and decide as a community what that needs to look like. And we would love to be a part of that effort, but to the extent that we're able to participate. But we didn't want to, it's just wrong of us to just arbitrarily declare, that's just, anyway, so I'll leave that there. So when we establish context through the tool, it's important to remember that encapsulation, all of the definitions have to be in the model, have to be in the unification tool. Everything that's in the unification tool needs to be in the model. So they dovetail. There's a symbiotic relationship there. And it's important to remember, I've said this 100 times already in this one presentation, that encapsulation establishes context, and that the fundamental issue all along has been context. We have been assuming everybody has the same context because we assumed we were dealing with physical reality rather than an abstraction of it. We never thought about having a logically correct model before, and now we are. And that context is established by the encapsulated models. We put those in the translation matrices, and then we layer them against the analytics. The mathematics doesn't change, but what is mode shifted across the plurality of models is the context in which it is applied. And so that last bullet on this chart is the reason for this whole set of charts and this whole presentation here. The mechanics of mathematics doesn't change. The way we think about mathematics doesn't change. There's no new math in any of this. All the math is essentially the same. And it doesn't matter who we're talking about. We have folders in the biography section of the user library on people from Pythagoras to Lorentz to Einstein to Niels Bohr to, there's over 100 people there. And a lot of the papers that they all produced. And so for example, we don't write text and say, we don't tell you what Maxwell said. We show you what Maxwell said. We present his actual paper. where he said what he said, and you can go there and look at it for yourself. And when we do that, we short circuit a lot of hearsay and other kinds of things that's eliminated, so that we can get to the. That's important when we start looking at the unification tool and the definitions that are made there, because I guarantee you, how Maxwell thought about the medium is different than the way you think about the medium of the realm in which we exist. And so, we don't talk today about the luminiferous ether anymore because of the Michelson-Morley experiment, etc. So there's a ton of different examples like that, or those examples. But the point is that the mechanics of the mathematics doesn't change, and there's not really any new mechanics being applied to any of this. So here are the 7 interpretive models. There's actually 8, but one's reserved. It's a long story here. I talked about that in the earlier video. Each of these is linked back into the website. You can go look at them there. But how there's each color difference on this 2D articulation frame here of the translation matrix establishes the context for that model relative to the given set of paradigms of interest that you may have for your investigation. And so for each intersecting cell there would be a requirement for you to explain how that particular model manifests that particular paradigm. And that's what the next chart on the rows is. Same thing. We talked about that in the earlier videos. I'm not going to hit it hard here, but it's just the rows are the paradigms of interest for your given, or of nature, for your given investigation. The top layer of all that, once it's completed and filled out, is what we call the 2D articulation layer, or articulation frame. And we take that and then lay it over on its side, and then stack it on top of these other analytical layers, which I talked about in the earlier videos. I'm not going to go across them here, but that's what they are. You can go watch the other video and get that other detail, or you can click them and go look at them in detail on the website. Mode shifting concepts. So whole concepts must be mode shifted in order to assure that the mathematical thinking behind them has any integrity associated with it. To some degree, it's akin to thinking like an engineer. I was thinking earlier about what to say here, and it's not obvious. If you pulled up a manual on aerospace engineering today, there are hard-won equations in that book or that paper, whatever you're looking at, that do not describe the human blood that was spilt to come to understand the truth of that equation. In the early days of building airplanes, we just did stuff and we were trying it out. We didn't understand stability. We had to go test it in the field. And if mathematics alone was all we needed, we wouldn't need to test anything in the field. But we do need to test things in the field because we are not sure the math is correct. And an engineer understands that. And that's what I mean by that statement, is that there's an engineering aspect to all of this that requires it requires empiricism, it requires empirical testing, but again, empiricism is a subset epistemology of elegant reasonism epistemology. We never need to lose sight of that. And I'm not saying that empiricism is wrong, it's just that it's linked back to human physiology, and when we do that, we are prone to commit Langer epistemology errors, and we need to move away from that or minimize that to the extent that we can. We need to be in a mode where we're thinking in terms of systems and systems of systems. Under M1 or M2, a real object is generally construed to be a manifold of space-time due to energy. That's why you might hear somebody say something like, we're all just energy, or that, there's a lot of energy in that atomic bomb because we convert it all. Well, there's some of it is, certainly, and some of it's not. So when we look at these things, we need to start asking some really hard questions. Like, we can use E equals mc squared, for example, to talk about what happens when real mass traverses the space-time mass interface, and it's converted to energy. And this, by and large, is one of the reasons that the quantum gravity guys are chasing a red herring. What happens to the geometry of space-time when it becomes mass? Is it a separate bubble? Is it dragged inside the manifold? What is the surface tension of space-time in that case? What is being assimilated? What is the tension, the stress, etc.? And if we look at the universe as defined by the Big Bang, and we say that the Big Bang created space-time, then where was it when it banged? And you can get into some pretty interesting theoretical discussions here that require us to understand what exactly is allowing us to that version of the universe to expand, or expand at the rate that it's expanding, etc. And we could have those discussions in we probably will have those discussions in another video. But anyway, the point here is relative to root cause analysis and the 5 whys and QMSs, and the overarching processes that we use. And we do that because we have to keep asking why. We have to keep digging and digging and digging deeper to understand the implications of the constructs that we may just assume in a given investigation to be true. But we are liberated, absolutely liberated, when we realize the logical nature of M1. And that means that all the formulas that are stereotypically associated with M1, if you realize that those are, if you pick up a big engineering book and you look at that whole set of equations and they're all based on M1, and you realize that those are logical descriptions of a logically correct model and a logically correct interpretation, but there's another also logically correct way to think about any one of those given equations, and that we can establish a way to mode shift between the M1 version of the equation and the M5 version of the equation, and they are both simultaneously correct. That's a powerful capability. It's a very, very powerful capability. Okay, so let's talk a little bit about metrics. Metrics are formal elegant reasonism, or in a formal elegant reasonism treatise, will employ them to be compliant with relative, respective, and appropriate ISO documentation. ISO is the International Standards Organization. Metrics should generally be construed within the given goals and objectives of the investigation being undertaken. And again, we talked about that earlier when we talked about the source of the guidelines being handed down in terms of objectives and goals. You want to make sure that they are consistent with the unified universe. These are pretty straightforward bullet points. I'm not going to spend a whole lot of time on them except to say that the taxonomy coherence down at the bottom there needs to be cogent. It needs to be cohesive. It needs to be coherent. It needs to be communicative. It needs to close to unification. There's a whole set of C words that we use to go back and constantly in any given investigation to make sure that all of these things are doing what they're supposed to do in delivering the result that is ultimately delivered. And we want to make sure that Langer epistemology errors are minimized or eliminated, preferably eliminated, and that we've effectively integrated systems engineering principles, practices, and methods. We understand what a logical view is versus a physical view, and we're not confusing those things, and that we can mode shift between different logical views of the same sets of equations or the same sets of paradigms of interest. And that way that we don't get confused. And so we can also back up from that treatise and say, okay, well, and it's helpful if you, in terms of being able to deliver education roadmaps, in terms of probably communicating back with management about why something is true, and why a given conclusion is justified in the manner that it is. Because some of those managers are potentially spending considerable sums of money and human resources against the conclusions that you come out of with this investigation. And so they're going to want to see the metrics. They're going to want to know that this investigation has solid quality metrics associated with it, and not just because of they're trying to win a Malcolm Baldrige Award, but because they're trying to make sure that their money is being spent effectively, because they have to answer to shareholders. Holistic translation matrices. Once completed, the translation matrices may, you can consider it a machine for context switching modes of thought across the plurality of models that you chose to employ in your investigation. You can have multiple logical views, and you can use these mechanisms in a presentation when your investigation team is going back to a net new audience that's not familiar with the intricate details. You can use some of these techniques the same techniques that you use to discern the insights that you got, you can now use to communicate to other people. And that's a powerful capability, because it shows that you're doing everything in a quality management oriented manner, and that you have documented how you got to where you are. It's not just an assertion. It's not just a claim. It's not just, you're not pulling it out of thin air. And you also have to know that there's multiple logical views of the same physical system are allowable. You can even have multiple physical views of the same logical view. There may be more than one way to do something. As an example, if the something that you're trying to do is a logical view, there's multiple ways to get it done, then in each one of those logical views, so you may have an investigation that has, and I'm just pulling these numbers out, just so if you have M5 dot and 4 zeros, that's the first instance of M5. You may have M5 dot and dot 10 and dot 50, and you also may have M6 dot 1, 2, 3, 4, 5, and 6. All can cogently represent the same paradigm of interest for M5.12. And so those permutations are something that you really need a very large computer and a relational database system to handle and process in an effective manner, so that it can be used by an enterprise or an agency or a academic group or whatever. And that's part of the reason all of this represents the huge opportunity in computing that it does. Predicate priority, it should be philosophical predicate priority considerations, penetrating all investigation decisions. It must close to unification, or it has to declare why it cannot. So for an example, in M1's never going to close to unification exactly because the core constructs preclude it. And I specifically refer to the space-time mass interface. The holistic purpose of mathematical proofs must have affinity with the unified universe or be constrained by the encapsulation which cannot demonstrate such affinity. The purpose of a mathematical proof is to take all of this into account, not just the traditional things we would relate on a mathematical proof. We have to be able to say that equation 1, 2, 3 in M1 cannot close, it may be true, but it can never close to unification. Therefore, we must mode shift these equations to M5. M5 carries those forward because A, B, C, D, E, F, whatever those reasons are. And then we can show how we can mode shift between those two things to show that M5 is the better description for what it is we're trying to accomplish. And there's very likely going to be a set of insights that come as a result of that. And that's what we mean by the holistic purpose of a mathematical proof must have affinity with the unified universe. That's what I mean when I say that. So the implications of mode shifting, model-to-model comparisons are never accomplished from within any given model relative to the other. The comparisons are always done in the context of the analytic framework and tools under the rules of engagement, which in this case are Elegant Reasonism rules. And again, the mathematics doesn't really change. There's not really any new math here. It's just being applied domains of discourse are established for each of the interpretive models, each of the analytic layers, paradigms of interest, etc. And then some of those analytic layers are vertically oriented on that matrix, and some of them are horizontal. Some of them are, cover permutations of things across models, so that we can analyze the insights and demonstrate logically why the M5 view is the better view, or the M6, or the M7, or the M12 if somebody comes up with a better model than M5. Systemic implications must be fully exploited, illuminated, and illustrated across all domains of discourse. So, for example, when we did the bang to bang article and we were able to show that at certain distances gravitons reverse polarity, first of all, we realized that they have polarity in the first place, and that they are consistent with Euler's beta and gamma functions, for example. We realized that why and how that big bang event, as it's manifest under M5 rules, can occur, whereas in M1 there's no mechanism for that to occur. It doesn't make any sense for that to occur. And what we find is that we really very seldomly use words like infinity in the emergence model. They're really big numbers, they're really huge numbers, but they're not infinite numbers, they're finite. The only thing that's really infinite is the actual real universe, which is a different discussion we're not going to get into here. And it's very seldom used that way. So anyway, but the point is that for a given model, and in the domains of discourse, we have to mode shift that and maintain the mathematics within those applications. So let's talk about a specific example here. So I used this in the earlier presentation, in the earlier video, and it is a letter from Einstein to Lincoln Barnett, and it was we used this as to demonstrate the distinctions between M1 and M2, and in that part of the conversation, Einstein's just making the point that he doesn't think mass is variant, is essentially what he's saying there. So if mass is not variant, why are we allowed to square it? Does that make any sense? No, it doesn't. And And the sheer fact that we are allowed to square a number for which we declare nothing can exceed is a paradox suggesting the logical nature of the models employing the construct. And so that's an example of a clue that's left by the unified universe, that your thinking is logical in nature rather than a physical thing. So M5 is a complex composite architecture comprised of configurations of MBPs represented in this case by I and then the complex C. And we will take action as the fourth dimension there. The MBPs are the manifestation of the first three dimensions. We have those three dimensions because the MBP is three-dimensional. And then use the subscript of M. The value C definition. The value C, when we mode shift that, it gets reassigned from the speed of light to severance. That's an important thing, number one. Number two, it results in the same velocity, but the reason it's true is different. And there are some implications of that. When we go look at, we dismantle the limitations of C, we understand that interferometers and other measurements that we use to determine the speed of light all produce the same speed because of severance of all the machines is the same, because they're all configurations of the same MBPs which have the same severance value, and it is the system that produces the photon that is, it's the limitation of the system to produce it at that speed, not an external imposition of a dimensionality of something that doesn't exist in reality. And so when we do that and we realize that photons are going the speed they are because of the system that produced them rather than a dimensional imposition, we go back and say, well, is that really the ultimate speed? And we suddenly realize that all of Hubble's data that he worked on is vindicated, and that we find that the Z factor that's expansion of space-time in the inflationary theory, for example, is actually multiples of the speed of light. And they are cosmological variances that are superluminal. They are in fact multiples of the speed of light. We then realized that rapidity is a term that was used about 1900 and earlier that got superseded by relativity when Einstein's rule came out. But rapidity is V over C. And when we realize that C is severance, not the speed of light, then rapidity takes on a whole new meaning. There's a whole new application of thought that can be applied there. And that the velocities that are vindicating Hubble are just that. And that we realize that rapidity is infinite. And I'll mention here too that every particle accelerator on Earth aligns does their beam alignment using rapidity. And that would be another logical clue that the universe has been trying to tell us something for a very long time. So the implication is that rapidity may exceed severance for all real objects accepting individual MBPs in our universe. And that gives rise to that bang-to-bang discussion that I was mentioning earlier that's on our website. You can click that link there and go read that article. And so we suddenly have an ability for Elegant Reasonism and the Emergence Model to describe the universe bang-to-bang and simultaneously answer all these other questions at the same time. And I will say that that's one of the beauties of having a fully aligned treatise, is that once you do that and you've connected it back with another fully aligned treatise, the body of knowledge becomes completely cohesive and completely compliant with the realm of C's as a collected set of information and knowledge. And that's more powerful than I can convey. It's just incredible. Mass, and example 1 here, I think we've talked about this already. Yeah, we have, I think. So I'm going to go on by this. Example 2 is cosmological velocities. We just mentioned that a little bit about rapidity. I think I've talked about that one as well. Example 3, the nothing versus something discussion. In M1, we're really limited because you have to consider whether or not you consider space-time a real object. If you consider it a real object, then under M1 rules, there is no such thing as nothing. Everything is something, including nothing. In M5, that's not true. M5 is dimensionless nothing, and everything else is some configuration of MBPs. And so this gets back to mode shifting and how we employ mode shifting. Mode shifting is not just a change in the set of math formulas that you use. It requires a complete manner of contemplation to change from M1 to M5. And the fact that you can back each of those up to demonstrate simultaneous truths as you pursue the truth that is aligned with the unified universe, then you have a very powerful process. And that's what Elegant Reasonism brings to the table. Example 4, Bayesian analytics and statistics. Bayesian analytics is a really cool part of statistics. It integrates belief systems into the analytic rigor before, during, and after a given investigation, and at each step and stage. And so, I only have, and I'll just say this as a general point for the analytics stack of a translation matrices. Don't think that because we have one defined layer there that there's actually one real layer there. There may be multiple layers for each of those things. And so use as many Bayesian layers or as many logic calculus layers or whatever to support your investigation if you need to. Those are just epicenters, centers of gravity, if you will, for the kinds of work that's being done at those levels. The point is you have to have enough content there to get to the holistic insights that are driven by the unification requirements and affinities. And I'll give you some examples. When we realize that action plays the part in M5 that it does, and we can carry that up, and we can carry it up through biology, and we can carry it into the central nervous system, and how axons fire and ultimately connect together into neural networks and are part of how human beings are made manifest. And we understand how the brain processes of consolidation and learning take place and memory occurs. We can then carry forward to external ideas external to the human being, and we run into trying to connect other realms of endeavor that humans may do, and we come up with one that's economics, for example. And a guy named Ludwig von Mises wrote a fantastic treatise called Human Action, and it is a treatise on economics. And he goes through the descriptions of the physical, tangible, human actions that impact economics. But in every step and stage when he goes through that document, he relates it back to the specific human actions that transpire there to make that happen. And when we realize the implications of action and human action back through human physiology again and all the way back down through the physics, we suddenly are able to connect his treatise on economics with Elegant Reasonism and the Emergence Model and connect it back into the bang-to-bang thing. And so when I say that unification is a much larger tapestry than any given single discipline of science, that's what I'm talking about. It's the ability to relate all of these different areas of human existence to the same cogent description, the same paragraph. So unification is very, very powerful. Constructs and abstractions. Boundaries. M1 defines the Big Bang in a manner, that it's rationalizing manifestation of space-time, including the expansion of it, in order to explain galactic acceleration. So there's this phenomena that we see from the astronomers talk about the galaxies flying away from each other, and they don't have any. They're actually moving away from us at speeds greater than the speed of light. And because Einstein said nothing can go faster than the speed of light, because of the interferometer experiments, they had to have a way to explain that. And so they said, well, space-time itself is expanding, and it can go faster than the speed of light. And that's an example of an ever-increasing elaborateness of rationalizing something also. But the boundaries are what we want to talk about here, is that what if it's expanding, what is it expanding into? And why is it allowed to expand? And is it allowed to expand forever, et cetera, et cetera, et cetera. So there's all kinds of, this gets back into the nastiness of the space-time construct, all of which are clues. So, but you have to ask, are they defined in are the abstractions and constructs defined in such a way that unification was a philosophical predicate priority consideration? And in the case of space-time, no, it wasn't. And Einstein himself said that he was not trying to unify physics when he wrote Relativity. Either paper, the 1905 paper or I'm brain dead. I can't think of if it's 1916 or 1926. But anyway, the later paper. Are they scale invariant? Are they variant? Are they dependent on a particular scale only? Is a holistic constituent potentially a composite system of systems? That is to say, are they nested? Are systems nested within systems? All of these are questions that you have to think about when you're going through that illumination phase of the translation matrices. Going forward, theoretical mathematics must not only ensure the integrative of the traditional proof, which would be inside a given encapsulated model, but it now has to be mode shifted with any other model that exists. And I remind you that at least one of the models that's employed must close to unification. If at some later date somebody comes up with 2 or 3 other models that also close to unification, that's fine. Then we can put all those other models. We still have to go through the same analytic stack and same general process. And the mathematics will again probably not change, but how we apply it probably will. But that's to be expected. This is one of those charts that I would, if I was giving a presentation to an audience, that I would stop and ask questions for, and I know that you guys probably have a lot of them that I'm not talking about, and that's true of some of these other charts that we've already passed. But so you can read this as well as I can. I'm not going to read it to you. Obviously, the point of an elegant reasonism proof is that it takes a given set of interpretive models and it effectively enables them to be mode shifted and ultimately come to a set of insights that are consistent with and can be held litmus against, or the unified universe can be held litmus against the treatise and demonstrate the truth of it all. Because we have the Bayesian analytics, we have the belief systems from other models. So if there's a given set of group of people that are adherent to M1, the investigation can say, we understand that belief system, but here's why we need to mode shift that over here because of reasons A, B, C, and D. And it gives us a credible transmission, if you will, if you allow me a car metaphor, to be able to translate from M1 to M5 and back again. We offer up the body of work that's on SolREI.co to serve as an ISO guide. If you go look at what constitutes an ISO requirement, Elegant Reasonism is not yet listed with the ISO organization. We have sent them notes and email notes, and we are offering up SolREI.co as the ISO guide to Elegant Reasonism's framework and epistemology. And at some point we will have a tighter relationship there. Right now we just don't have the arms and legs and resources to do that. It's one of the things that we would love some assistance with, but we're not there yet. Over time, the intention is to integrate the body of work on the network for everybody to engage as appropriate. Langer epistemology errors are noted, quantified, codified for recognition, illumination, and analysis. And so that's the discussion about mathematical proofs and how an elegant reasonism proof differs from a traditional proof. I thank you very much for your time today, and we will see you in the next video. Thanks a lot. Take care.